Hello everyone, this is Dr. Sudip Mandal. I am the Assistant Professor of Chemistry and School of Applied Science and Humanities at Vignan University, and I will be teaching engineering chemistry course, and as a part of the engineering chemistry course I will be discussing one topic in one of the units. So, that is actually lithium ion battery. Okay. So, this is a part of the electrochemistry and batteries unit, okay, in unit 4. So, okay. So, we will be discussing on the lithium battery, what is the working principles, okay, how do you construct them, and what is the reactions inside the cell, and what are the applications, their advantages and disadvantages. So, before moving towards the lithium battery, we need to know some basics of batteries and their advantages and disadvantages, and what are the components are involved. Okay. So, let us start. So, I will be discussing, these are the contents. So, first we will discuss what is the electrochemical energy systems and what is the introduction of batteries, then what are the components are involved in the battery, then what are the characteristics features in a battery and their pros and cons, that means advantages and disadvantages of the battery, and what are the classifications, how do you classify the different types of batteries, and like primary batteries, and we will be discussing on secondary batteries, and in secondary batteries we will be discussing more specifically on lithium ion batteries. So, this is the electrochemical setup, which is called 3 electrode electrochemical systems. If you see, this is a very simple setup where you can see we have 3 electrodes. Okay. So, where there is a WE which is corresponding to working electrode, or you can call it as anode, then you have a counter electrode that is called basically cathode, and you have a reference electrode through which you can apply the potential. Okay. So, basically in working electrode we generally use electrode which is having like glassy carbon, okay, which is carbon which is electronically conducting, and in general counter electrode we use platinum, and there are several reference electrodes are there, and especially we use saturated calamine electrode or silver chloride electrode. Those are basically all secondary reference electrodes. So, we are just introducing you what is basically an electrochemical cell. Okay. So, there are basically 2 types of electrochemical cells. One is called galvanic cell or voltaic cell, and another one is called electrolytic cell. So, galvanic cell or voltaic cell is nothing but where the chemical energy is converting to electrical energy, and in case of electrolytic cell where the electrical energy is converting to chemical energy, that means to carry out the chemical reactions. Okay. So, that is basically the classifications of the electrochemical cell. Now, if you want to understand what is electrochemical energy systems, so is basically nothing but it is an electrochemical cells that can be classified into 2 types. One is called electrochemical energy conversion systems, another one is called electrochemical energy storage systems. So, in one of the systems where basically what happens, energy gets converted, that means what are the forms of energy are there, like for example light energy or chemical energy, all forms of energy will be finally converted to electrical energy. For example, there is a DSSC. So, this is called dye sensitized solar cells. So, in that particular electrochemical energy conversion systems, the light energy converts into electrical energy, or you may have to call fuel cell, okay, fuel cells. So, there basically chemical energy converts into electrical energy, okay, and you have basically fuel cell in your syllabus, okay, that will be discussed later on. Okay. And you have energy storage systems, especially whenever you convert the energy, you must need to store the energy in a certain device. So, by just converting you cannot have that energy. So, you need to use it in future. Okay. For example, solar cells are there, they are converting the energy in the daytime, light energy is converting to electrical energy, but finally that energy you need to use in the night time. So, how do you use it? So, you need to store that energy which is being converted, and that is where you need a device where you can store that energy. That is where the energy storage system comes. So, is basically in that particular category the batteries are involved. Okay. So, battery is playing a crucial role where actually you can store the converted energy in it, and wherever you require you can actually use it. So, whatever the batteries are there, like lead acid batteries, lithium batteries, okay, nickel cadmium batteries, a lot of batteries are there where you can actually store whatever the converted energy. So, basically you must integrate energy conversion system into energy storage system to store the converted energy. Okay. So, let us see what is exactly the battery is. So, battery is nothing but an electrochemical cell or voltaic cell, okay, that produces the electricity, electric current. Okay. And each voltaic cell, for example, one cell you are having anode, cathode and electrolyte. Okay. So, each cell having two half cell, okay, the two half cell can be combined together depending on your demand, okay, how much energy you need, okay, and that can be combined in a series or parallel way. Okay. And the last one is basically one of the half cell includes electrolyte and the electrode to which anions move, that is called anode. So, towards anode anions will be moving and other half cell which is called the cathode where the cations will be moving, okay, then through which basically the electricity produced. So, some of the examples of the stacking of cells where you can see the multiple cells has been put it together in a series or parallel combination to get the required energy. For example, if you are having a 2-volt cell, if you want to connect them like 6 cells together in a series combination, then you can achieve 12 volt, 2 volt into 6. So, that means in series combination if you connect 2 volt into 6 cell, that you can acquire 12 volt of battery. Okay, the simple lead acid battery cell, one box it is having 6 cells. So, 6 that each will be giving around 2 volt, that means you can acquire 12 volt of battery. Okay. But if you want to combine them in a parallel way, that means you are basically getting more current, but voltage will be still same. Suppose you want to get 2 volt of battery and you want to combine them in a parallel combination like 6 cells, then still the voltage will be same 2 volt, but your current will be added up. Okay, this is how we can actually acquire the required amount of voltage or current. Okay. So, let us understand what are the components of battery. So, very simple way to represent, you have anode which is called the negative electrode, from here actually the oxidation happen and you get the electrons, okay, and cathode which is called positive electrode, where actually generally reduction occurs, okay, during the discharge process, right. So, both anode and cathode should be electronically conducting, that means you should use certain metals as an electrode or any substance or any materials which should have very high electronic conductivity, otherwise you cannot use as an electrode. Okay, that is a very much required criteria for the electrodes, be it an anode or cathode, right. And next one is basically electrolyte. So, what is the role of electrolyte? So, basically where the ions are there, free ions are there, and that will be basically there in between the two electrodes. Okay. So, what is the features of the electrolyte? The electrolyte should have very high ionic conductivity, where the ions can move very faster. So, mobility of the ions should be very high, so that anions can go to the anode and cations should go to the cathode. So, there should be ionic mobility inside the cell, and you need a separator. So, what is the role of separator? Is nothing but separator is it prevents the short circuiting between the anode and cathode. So, when you put the anode and cathode in sandwich mode, for example, and you have a electrolyte, be it a liquid or any semi solid electrolyte. So, you need to have certain kind of insulating material, that is called separator. It can be any kind of plastic material as well, that should be again one more criteria, it should have porosity, it should be very much porous. So, through the pores the ion can move, right. So, the separator role is basically it will be preventing the short circuiting between anode and cathode. So, any battery you must have anode, cathode, and you have a separator which prevents the short circuiting, and you should have a electrolyte is basically nothing but any kind of salt. For example, aqueous based electrolytes like KCl, potassium chloride, sodium chloride, potassium nitrate, where you have basically K plus and Cl minus, KCl, right. So, you have cation and anion. So, similarly different types of electrolytes also there. So, it should have some kind of ionizing ions, where the ions can move to corresponding electrodes, right. So, what are the characteristics? So, if you have a battery, what characteristics you should have for a battery? For example, the size, what size actually defined. So, you have seen this kind of battery, AAA, AA, okay, C, D. So, these are the different types of battery you can see here. So, this is AAA, AA, okay. So, what you are seeing is basically your size is varying. So, what does it mean? So, if the size is varying, so you have more number of or more amount of materials you are packing inside the battery, but still the voltage is same. AAA and AA battery voltage is same, but what is that changing is the capacity. As we are putting more amount of material inside the battery, your capacity is changing, so you can get more amount of energy from the battery. So, AA battery will be having more amount of energy than AAA battery. So, you can see that AAA battery we are using in TV remote and in different like small watches and all, but AA battery we are using in several other applications where you need more energy. Then you have C, D and all, where more amount of capacity we can gain, right. So, next is the longevity. So, the battery should have very high longevity, it should run for a long time. So, that means how do you define that? That means you must have very high capacity, which is basically the ampere hour, current multiplied by time, which is nothing but called the capacity. And second longevity is basically number of recharge cycle. So, how many times you can recharge and still the battery is going well. Okay. So, that means battery should run longer time. Okay. So, next is discharge characteristics, that is called voltage drop. So, over the time your battery's voltage should not drop, it should be almost constant, otherwise your battery will be degrading very fast. Okay. Next one is very important parameter, it is called energy density. Okay. Energy density is nothing but the watt hour per kg or per centimeter cube. Okay. What does it mean? Energy density is mean nothing but, so total amount of energy that can be stored per unit of mass or volume. How much energy you can store per unit of mass of the material or the volume of the material. Okay. And how long will you get the energy? So, how long, for example, how long will your laptop run before it must be recharged? For example, once you recharge your mobile phone or the laptop, how long it can run? That will define the energy density. One more important parameter is that is called power density. What is power density? That is watt per kg. This is watt hour, that means how much power multiplied by time, and here it is watt. Watt is nothing but volt into ampere, voltage into current, that will give you the power, how much power you are having. Okay. So, it is nothing but maximum rate of energy discharge per unit mass. So, at a short period of time how much energy I can get, that is called power density, right. In a short period of time how much energy I can drag, that is the power density, right. So, these two parameters are very important parameters for a battery. Next is the cost. Okay. So, cost of a battery should be optimal. Okay. It should not be very high cost. So, cost will come again what kind of material you are using inside the battery, that will be defining the cost. Okay. And next is basically safety. Safety is very important. So, battery should not explode, battery should not have any kind of hitting effect or any other. So, safety is very important for a battery, because you will be carrying it with you. So, behavioral factors like temperature range. Okay. So, temperature range is nothing but what temperature you can store the battery. Okay. So, for example, here the temperature is around 35 to 40. So, if you are carrying the same thing in certain place where the temperature is around -10, so whether battery will work or not. So, again that means what is the material you are using, that means what electrolyte you are having or what material, that material should be stable. Okay. So, that means that is the storage operation. Okay. What temperature range it can have, it should have very broad temperature range. And self discharge. Self discharge means once you charge your battery fully and keep it as such without any use or without dragging any current or something, just keep it as it is without any using. So, then you should monitor how much voltage is getting dropped. If it is not dropping anything, that means self discharge is 0. If it is dropping, that means the battery is discharging by itself without even you are not using, right. So, that means self discharge should be very low. So, these are the batteries features or characteristics you should look for a given battery. And one more is called environmental factors, that means you should not have any kind of toxic substances which is being used in the battery, and if you like, for example, your battery is dead, if you are throwing it, it should not cause any kind of environmental effects like pollution and all. So, you must also see the environmental factors like leakage, gassing, any kind of toxicity and all. Okay. Right. So, what are the advantages of batteries? So, there is no need to be connected to an electrical system. So, if you are having, you can just use it wherever you are want. I mean, you no need to connect your device to any electrical system. If you are having a battery, you can connect to that and you can use it, right. So, it acts as a portable source of energy. So, it is a mobile device, right. It can be replaced easily, you can remove it if it is not working or it is dead, you can replace with a new one, right. And different types of batteries have their specific applications. For example, the primary batteries, which is nothing but the use and throw batteries, okay, are commonly used in like electrical watches or any medical devices, okay. And secondary batteries, which are rechargeable batteries, okay, generally used in portable equipment like portable radio, television, mobile phones, laptops, etc. Okay. So, we will be discussing more on this primary and secondary, what is that exactly, okay, means in terms of chemistry aspect, okay. And these are the basically different uses of batteries, like lithium batteries we are using in different places like space application, consumer electronics, okay, electric vehicles, this is very important one which is coming up, okay. Then defense sector, solar and wind energy system where they are basically storing it, telecom towers, marine submarines, okay, and different field, okay. This is very few I have mentioned here, but there are many applications are there, right. So, disadvantages. So, you need to also look for what are the disadvantages of a battery, right. So, it can be used for only a limited time, even secondary batteries also can be recharged only certain number of times. So, maybe 1000 cycles can recharge. So, for example, a mobile battery after 2 to 3 years you have to replace it. So, it is not a lifelong solution, right. So, that is one of the disadvantages. Second is, some of the batteries are dangerous and can lead to fire explosion, okay, or environmental hazards. For example, lead acid battery. So, lead is very toxic. So, if it is not working, if you are throwing, so lead will be giving some kind of environmental pollution. So, right. So, certain batteries depending on what materials you are using, okay, that will give you some toxicity. So, that is one of the important parameters or important factors that you should use certain materials which does not cause any kind of environmental pollution or any kind of effects, right. And for example, lithium batteries, which is basically are using in all electronic gadgets that are bit expensive, okay. And some of the batteries need to be maintained and checked periodically, like for example, temperature, sealing or any kind of electrolyte leaking, that is called battery management. So, some batteries are having this thing, like we need to check it periodically, okay, and to see whether this effect is there. So, that is one of the disadvantages, okay, of the battery. Coming to the classifications of the battery, what are the different types of classifications, okay. So, batteries are basically classified into two ways. One is called primary, or that is also called non-rechargeable battery, right. And for example, the alkaline battery, manganese or zinc carbon battery, okay, we are using basically, this is basically called use and throw battery. You just put it inside and whenever the voltage is gone, then you can throw it out, okay. This is the primary batteries. So, it is only single use. And you have a secondary batteries, that is called rechargeable, like lithium batteries, we can recharge multiple times and we can reuse it, okay. For example, lithium battery, lead acid battery, sodium battery, okay, zinc battery, nickel cadmium battery, all are secondary batteries or rechargeable batteries. They can be used multiple times after recharging them, okay. So, let us see what is actually primary battery. So, primary batteries is basically indicating that meant for single uses, and so once these batteries are used, they cannot be recharged. And as the devices are not easily reversible, the active materials may not return to their original form. That means, whatever the materials you are using in the primary batteries, right, these whatever the reactions also involved in the battery, they are not reversible, they are irreversible in nature, okay. So, that means, if you want to recharge them, whatever the final form is there, that will not come back to the original form, the initial form. So, it is basically the reactions which are involved in the battery which are irreversible. So, that is why whatever the stored energy was there inside before using, once that is converted to some other material, the energy will not be reverted back while recharging. So, the reactions which are involved in the primary battery, they are irreversible, okay, they are not reversible. That is the reason it is a single use, okay. So, for example, dry cell, okay. So, we use basically 2 electrode and we put some kind of paste, electrolyte paste, okay. So, they react with the electrode and produce the charges and the current, and that is the basic mechanism of the primary battery. So, we will come to the examples. For example, carbon zinc dry cell, alkaline cell, zinc chloride cells, okay, mercury cell, silver oxide cells, okay, lithium sulfur dioxide cell, or lithium thionyl chloride. So, these are not used nowadays, but normally what we are using basically this alkaline cell, okay, where you have basically, you know, this is the basic battery, okay, features. Okay, how do you see that? So, basically you have a basically one electrode, that is basically carbon rod, okay, and you have a zinc can which is acting as anode. So, this is a cathode and this is anode, okay, and you have basically some paste of, you know, manganese dioxide, NH4Cl, ammonium chloride, zinc chloride, and in water, so aqueous kind of thing. So, that means here basically zinc is anode and manganese dioxide is cathode. This is a corresponding reaction during the discharging process, that means when you are using, okay, and this is what the cell voltage is 1.43 volt you are getting. Okay. So, zinc is basically undergoing oxidation, producing zinc oxide. On the other hand, manganese dioxide, which is cathode, is converting to Mn2O3. Okay. And this is what the basically cell reactions in each half cell, and this is the overall reaction. Okay. And this is the cell voltage of the battery, which is typically 1.43 volt for a primary battery. Okay. So, let us see what are the basically uses, okay, applications of the primary batteries, like flashlights, okay, transistor radios, wall clock, camera, okay, calculators, hearing aid, TV remote. So, all, you know, these basically applications they use basically primary batteries. So, this use and throw batteries. Okay. Now, coming to the secondary batteries, right. So, secondary batteries are basically called rechargeable batteries. That is nothing but the materials what we are using, they are reversible in nature. So, the chemical reactions involved in that materials are basically reversible in nature. So, you charge or discharge. So, whatever the forms of the materials in the initial converting to final, again final can be converted to initial. So, this is a reversible process. For example, if you have A to B, okay, this is what happening during, you know, discharging. So, again B to A, it will be coming back, okay, during charging process. So, they are usually assembled with active materials with in discharge state, so that you charge it, again it will be coming back to the original material. Okay. So, then rechargeable batteries are recharged by applying electric current, which reverses the chemical reaction, that is what the reversibility, okay, that occur during discharge process, right. So, some of the examples like this is a lead acid battery, okay, like nickel cadmium battery, okay, or even lithium battery. So, these are all examples of the secondary batteries, right. What are the types of secondary batteries? We have basically nickel cadmium, lead acid, lithium battery, right, sodium ion battery, lithium sulfur, sodium sulfur, zinc oxygen battery, zinc organic battery, redox flow battery. Actually, these are all not commercialized. So, these are the commercialized. Nickel cadmium we are not using nowadays, basically we are using lead acid battery extensively in all stationary applications. Lithium battery we are using all mobile application, like, you know, electric vehicle, mobiles, laptops, all portable devices we are using this one, you know, lithium battery. Lead acid battery we are mostly using in stationary because it is very heavy. Okay. We still use in, you know, in portable devices, in like for example mobile devices, okay, like buses, okay, vehicles and all, but this is mostly all electronic gadgets are, you know, made up, you know, lithium ion batteries. Okay. And these are the batteries, still research is going on, which is not being commercialized, right. So, what are the uses of secondary batteries? So, they are used in cameras, calculators, pacemakers, portable radios, TVs, you know, all telecommunication equipment, instruments, okay, medical devices, and they are used to operate in laptop computers, in mobile phones, okay. And there is, you know, mostly, you know, supplying the current mainly automobiles such as cars and all, okay, electric vehicles. And it is also used in gas engine ignition, okay, telephone exchange, hospitals, power stations, etc. Okay. And let us see, just overlook, you know, just what is the difference between primary and secondary batteries. So, primary batteries mostly it's a galvanic or voltaic cell, and it produces the electricity, and it is a secondary battery is also galvanic voltaic cell during discharging process, but it behaves as the electrolytic cell during charging process, because in charging process you are supplying the current and carrying out the chemical reaction. That is why it is behaving as a electrolytic cell during charging process, but while you are discharging, that behaves as a voltaic or galvanic cell. And the cell reactions are irreversible, the cell reactions are reversible, and it cannot be recharged, it can be recharged. Okay. This can be used as long as the active materials are present. Once entire active materials are converted to certain product, you cannot use it. So, it can be used again and again multiple times after recharging. Okay, some example like dry cell, like Lanchester cell, lithium cell, and this example, so lead acid battery, lithium battery. Okay, so these are the some of the places where you apply. Okay. Now, directly coming to the lithium battery, as this is the topic of today's lecture. So, you must know this 2019 Nobel Prize, which was given to the 3 scientists because of the development of lithium batteries. Okay. So, John B. Goodenough, okay, Stanley Whittingham, and Akira Yoshino. So, these are the 3 scientists. He is from Japan, he is a British American, and he is American. Okay. So, these 3 scientists actually developed lithium batteries and commercialized. Okay. Because of that development is basically they got the Nobel Prize in 2019. Okay. So, this is the story what they have done, but we will be discussing more on what is there inside the lithium battery. Okay. So, Stanley basically what he has done is basically he started 1970, okay, using lithium intercalation in titanium disulfide, which is TiS2, as cathode. Okay. So, John B. Goodenough actually increased the voltage window of the lithium battery by using cobalt based material, okay, cobalt oxide, and making it very powerful and practical. Okay. And Akira, he created the first commercially viable lithium battery in 1985 by using the petroleum coke. He is basically replacing the lithium with petroleum coke as a anode, which is basically carbon. Okay. During the refinery of the petroleum oil, we get this particular some kind of residue which contains rich enrichment of the carbon that can be used as a anode. Okay. So, this is what they have done, and because of that development they got the Nobel Prize. Okay. So, let us see what is there inside the lithium battery. So, what are the components? Okay. So, as I already told you, for a battery you must have 2 electrode, anode and cathode, and you should have separator and electrolyte. Okay. So, in the anode we have graphite. So, typically nowadays whatever the batteries you are having, in the anode you are using graphite as electrode, and that is also called host materials. Why it is called host materials, I will come to the next slide. Okay. Now, what is cathode? So, cathode you are using different types of materials. So, we started with lithium cobalt oxide. Here nowadays we are using lithium iron phosphate. These are the different cathode materials which we can use it. Okay. But nowadays in the battery we are using LFP, which is called lithium iron phosphate. Okay. Any one of that you can mention, right. Electrolyte, we typically use lithium, okay, hexafluorophosphate, lithium LiPF6 or LiBF4, okay, or any kind of lithium based salt. In this is the solvent. What is this solvent? Is basically PC and DEC mixture of solvent, which is called propylene carbonate. PC is propylene carbonate, DEC is diethyl carbonate. So, these are the high boiling solvent. Okay. So, it does not evaporate easily. So, you just take this mixture of this solvent and dissolve this particular lithium salt, which will give you the electrolyte, and you can add some additives as well to improve the performance of the battery. Okay. And separator is simple polymer, which is nothing but the polypropylene. Okay. So, propylene you just polymerize it, it will be giving a polypropylene, which is nothing but some kind of plastics. Okay. That is basically insulator in nature. Okay. And that is being used as a separator, which basically you are placing them placing it in between the anode and cathode. So, to prevent the short circuiting. Okay. And typical nominal voltage is a nominal voltage, which is basically be getting minimum 3.6 volt, but you can reach even more than 4 volt lithium battery, depending on what cathode you are using and what is the anode you are using. Okay. So, these are typical components of lithium battery. Okay. So, this is a basically schematic diagram you can see. So, this is what my cathode, which is lithium cobalt oxide for example, and this is the host material, which is graphite. Okay. So, we will come to that what is happening and all in a couple of slides. Okay. So, lithium-ion batteries are basically most popular nowadays, is very popular lithium batteries, right. So, that is because the popular rechargeable batteries, and is basically one of the example is very light. Lithium battery is very light, because the lithium is the lightest metal in the periodic table. Okay. That is the reason, and it is very popular because they can provide large amount of current. Okay. And it is lighter comparable to other comparable batteries, and nearly constant voltage. Once the discharge, the voltage will not be dropped. It can maintain the constant voltage during discharge. That is one of the biggest advantage. Okay, it does not lose even during the storing. Okay, so this is the main purpose why the lithium-ion battery is very popular. Okay, so let us see. As I said, why the graphite is called the host material. What is graphite? So graphite is basically one of the carbon allotropes. So graphite is nothing but is a layered materials. You know, graphene, a single layered, carbon, okay, which is basically sp2 hybridized, okay, and if you put all the graphenes in stacking mode, that will tell you basically that will give you basically graphite. Okay, so these are all black color thing is basically one layer. Okay, this is the second layer. So like this is the third layer. So it's basically stacking, and between these two layers you have a certain gap, and how they are basically being held. The two layers are being held through a van der Waals force, and the typical distance between the two layers is around 3 angstrom, right. So there is no chemical bond between the two layers, they are just physical interaction, non covalent interactions, okay, that is van der Waals force. Because of that it is being held, right. So that means there is a space, there is a certain pockets between the two layers, there is a certain pockets. So that is why it is called host material. That means it can host lithium ion, it can host lithium ion in between the layers. So that is why the graphite is called host materials. It can host lithium plus ion inside the or in between the two graphene layers, okay. And this is being used because this can store, okay, graphite can store high amount of lithium, many number of lithiums it can store, that is why it can have very high energy density. Okay. On the other hand, you have a cathode material, this is called LiCO2. Okay. So lithium cobalt oxide. So you have basically lithium, you have cobalt and oxide. That means what happens? Some amount of lithium will be coming out from lithium cobalt oxide, will be intercalated or will be placed in between the graphene. This is what is called the charging process. Okay. So you are extracting some amount, not all amount of lithium, some amount of lithium from the cathode, and you are placing in between the graphene layers. That is called the intercalation process, okay, by which you can store the energy. Okay. So let us see what is happening in terms of chemical or electrochemical reactions inside the battery. That means when you charge the battery or when you discharge the battery, what kind of electrochemical reactions are happening inside the battery, okay, that most of you are unaware of. So just using it, but you don't know what is happening inside, right. So to know that, okay, to understand that, so step by step I will be explaining the reactions, right. So during charging, that means when you are charging your mobile phone, for example, charging your battery, so that particular mode is called electrolytic mode. That is, that time the cell or the battery is behaving like a electrolytic cell, because you are applying current to carry out the chemical reactions. So in that particular time, so in cathode, which is nothing but LiCO2, their oxidation will happen. So again, so during discharging process, that behaves as a galvanic cell. So there what will happen? Anode will undergo oxidation, cathode will undergo reduction. This is the typical concept in galvanic cell during discharge. So but in charging process, that is behaving as electrolytic cell. That means whatever happen in anode, that is oxidation, that will be like now it will happen like reduction process during your discharging. Okay. That means anode, if it is happening oxidation in discharging, during charging process in anode, reduction will occur. Okay. That is why in cathode you can see, normally cathode what happens? Reduction, but in cathode as it is electrolytic mode, okay, so cathode oxidation will occur, that is called the extraction process. What is the extraction process? Extraction process is nothing but some amount of lithium, okay, you are taking out from lithium cobalt oxide. So let us say X amount of lithium, because I don't know how many lithium I am taking out during the charging process, I am just denoting it, X amount of lithium plus I am taking out. So X number of electrons will come out. So what is remaining is nothing but Li, it was 1 initially. So now it is 1 minus X, Li 1 minus X and cobalt oxide, CO2. So if you see what is the oxidation state of cobalt here is plus 3, because this is minus 4, this is plus 1. So cobalt is plus 3.
Now, here it will be almost it will be plus 4, because lithium still some amount of lithium is there, but that means there is oxidation process. So, cobalt plus 3 to cobalt 4 it will become almost plus 4, because still some amount of lithium is there. This is the oxidation process or extraction process, right. Next is what is happening in the anode. So, whatever amount of lithium you are extracting, that is going to be intercalated inside the graphite. Graphite I am representing as C6. Okay. So, then it will form LiX-C6. So, this process is called intercalation process. This is very important process. What is intercalation process means? Is nothing but you extract the lithium from the lithium cobalt oxide and place them in between the graphene layers. That process is called intercalation process. Okay. Then this is like two half cell reactions. Then you get a net cell reaction during charging process. Okay. So, LiCO2 plus C6 you are getting LiX-C6 and basically Li1 minus X CO2. This is intercalated graphite, lithium intercalated graphite. So, this is what that means during charging. So, when you are charging, once it is fully charged, your battery is fully charged, that means lithium is intercalated inside the graphite and it stored the energy. Okay. That is the charge state of the battery. Now, when you are just now you are using the battery, what is happening now? That is called galvanic mode. Basically, now what is happening? Whatever energy stored, chemical energy is being stored, that is being converting to electrical energy. Now, basically what is happening in the anode? So, the reverse reaction will occur. Okay. So, in anode, which is the intercalated graphite is there, that will undergo oxidation and it will release all amount of lithium and release the electron, and graphite will be free. And in the cathode, what will happen? Whatever the amount of lithium is being taken out from the graphite will finally converted to LiCO2. So, if you see that this process is reversible process, right. So, initially you have LiCO2, you converted to Li1x 1 minus X CO2, and again during discharging process you are just reversing the reaction. Okay. That is why it is called rechargeable batteries, because you can see that reversibility of the chemical reaction inside the battery. That is why it can be used multiple times. Okay. So, this is what the net cell reaction is during the discharge process. Okay. So, you can write this reaction in one way. So, by just keeping a double arrow, you can put oxidation, this will be a reduction. Okay. This will be again reduction, this will be oxidation. Okay. This form you can write, or you can write in this way. So, for better understanding process. Okay. So, let us see what is happening exactly. This is a schematic or animation video. So, this is what is happening during your discharging. That means, when you are using your battery, what is happening? So, whatever the lithium is being intercalated here, that is going back to the cathode, LiCO2 for example. Okay. During charging, what is happening? All Li, whatever the Li you are extracting, that is going and intercalating in between the graphene. Okay. So, this is what is happening inside the battery during the charging and discharging process, right. So, let us see what are the advantages of lithium batteries. Okay. They have very high energy density. I already discussed what is exactly energy density is, okay, and compared to any other rechargeable batteries. For example, 160% greater than nickel metal hydride, okay, or 220% greater than nickel cadmium battery. So, this very high energy density is having because of the high amount of energy is being stored, or lithium plus is stored inside the graphite, and they are very less weight. This is why it is very less weight, because of the lithium metal. Lithium is the lightest metal. So, that is why it is giving very lightweight battery. Okay. They produce high voltage, even more than 4 volt it can produce, okay, which is beyond nickel cadmium or lead acid battery, right. And it is very it is having very long shelf life. Only 5% loss is there, 5% voltage drop you can observe, okay, and compared to any other battery where the voltage drop is more. Okay. Shelf life is very high in case of lithium battery. Okay. And they have improved the safety. Initially there was a safety issue because of the anode, which they have used the lithium, but they have come up with the graphite. Okay. So, that safety issue has been improved, and the packaging and all, it has been improved. So, because of that, now there is no issue with the safety of the lithium battery. Okay. And there is no liquid electrolyte which you are using. So, there is no problem with the leaking. So, whatever electrolyte you are using, this they are mostly basically semi solid or solid electrolyte. Okay. And there are advantage of fast charge and discharge. Nowadays you are seeing you are coming up with a mobile phone, within 1 hour you can charge it and you can use it for throughout the day, right. So, the very fast charge and discharge is very important. For example, nowadays electric vehicles are coming, right. So, you are traveling with the electric vehicle and you need to charge it. So, definitely you will be not waiting for long time. So, you expect that your vehicle is charging within 1 hour. So, right. So, that means very fast charging is required. Okay. What are the disadvantages of lithium battery? So, there are still certain things to be worked out, okay. Like they are very expensive because of the lithium, because we do not get lithium in India, lithium we have to export it. So, lithium is very expensive because it is not earth abundant, okay. That is why the battery cost also increases. Okay. If this complete discharge can damage the battery. So, the lithium battery should not discharge to 0%. Okay. If you are discharging completely 0, battery may be spoiling, we are spoiling the battery. Okay. So, complete discharge you should not do. Okay. Extremely sensitive to high temperature. So, that is one of the disadvantages. So, if you are having very high temperature zone and all, you cannot be using the lithium battery, for any stationary applications and all, right. And very short lifespan. So, only 2 to 3 years it can have. Okay. After that you have to replace the battery. So, that means the recharging cycle maximum it can have 1000 to 2000 cycle. After that means it will only run for 2 to 3 years. Okay. After that you have to replace. That is one of the disadvantages, and not available in different sizes, like primary batteries you have seen AA, AAA, C, D, different version, but lithium battery is not available in those kind of different sizes, which is one of the disadvantages for various purposes. Okay. So, let us see what are the applications are there. Okay. As you know already, they are basically used in all electronic gadgets, okay, cameras, calculators, okay, pacemakers, okay, any implantable devices, okay, they are used in telecommunication equipment, okay, radios, right, in submarines and all, laptops, computers. So, these are the overall overview of, like nowadays the electric vehicles are coming up with lithium batteries. Okay. Nowadays what is the new company which is coming up, that is called BYD, China company, which are basically build the electric vehicle with prismatic battery of lithium battery. Okay. So, they are coming up with, all electric vehicles are coming up with the lithium battery. So, that is the electric vehicle which is booming. Okay. So, with this actually I conclude the lecture, okay, about the lithium battery. So, what you have learned today is basically basics of the battery, what is exactly batteries, or the classifications of the battery, like primary battery, secondary battery, right, and what are the components are involved in the battery, like anode, cathode, electrolyte and the separator. These are the 4 main components of the battery. Okay. And you learn the uses, applications of the secondary batteries, primary batteries, what are the differences between the primary, secondary batteries, and then we actually especially we discuss about the lithium battery, okay, how that is being constructed, what are the components, okay, and what are the electrochemical reactions are involved in anode and cathode during charging and discharging process, and they have certain advantages as well as disadvantages and their applications. So, with this I conclude. Thank you very much.